Good morning friends and welcome to a new session on stiffness matrix method. We are going to start with this method today and I will just give you an introduction about this method. This method is based on equilibrium approach, and this method is also known as displacement method. The basic reason for calling this as a displacement method is in this method our unknowns are displacements. That is, these displacements are of two types. One is linear displacement, another is angular displacement. That is nothing but rotation. So linear displacement small delta and rotations theta values are there. So these two displacements we have to find, hence stiffness matrix method is also known as displacement method. It is also known as equilibrium method because for solving this we are forming first of all equilibrium equations, and we are setting these equations in a matrix form and then solving it. So what are these equilibrium equations? Let us see. In a very generalized form, these equations are something like this. P1. What is P1? P1 is an external force or the final force in the member. This is equal to P1L. What is P1L? It is force or moment. P1 is force or moment in the restrained structure. What is restrained structure? We are making everything as fixed. So P1 is force or moment in the restrained structure, but these force or moments are because of external loading, plus K11 delta 1. What is K11? K11 is stiffness matrix of the member into delta 1. Delta 1 is the displacement or rotation on one of the locations in the structure, plus K12 delta 2 and so on, plus K1n delta n. So this is one equilibrium equation on our first unknown location. So what is unknown location? We will first of all find the degree of kinematic indeterminacy. Let us say it is 3 or 2, anything. And to each degree of indeterminacy we will give numbering 1, 2, 3 up to n, anything. So this equation is formed corresponding to our first unknown. Second equation will be formed corresponding to second unknown, P2L plus K12, it is 21, K21 delta 2 plus K22 delta 2 and so on. So up to K2n delta n. So like this we can form all the equations up to n number of unknowns or locations. So if you see, in general this is our P force, which is the force in the member. What is Pn? Pn is force in restrained structure because of external loading. So this force can be either axial force if it is truss, or it can be a moment if it is a flexural member, plus K delta Kn n into delta n So that's it. So if you see P is equal to P plus K delta, This is our generalized equilibrium equation, and this is our unknown delta. So we have to get this delta as delta n is equal to, you get this k on left hand side, so it will become k inverse. Okay, so this is k inverse into bracket p minus pnl. So if you solve this equation, first of all, if you frame these equations, form these equations, put in the matrix form, and then you will have to solve the matrix. So these are stiffness matrix elements. This is our unknown, which we will define in our very first step. So this equation is a superposition of equilibrium equation and compatibility condition. Okay, so these equations are framed or formed using equilibrium equation and compatibility condition. Both the things are superimposed together, and final matrix equation is framed like this. Okay, so this is the concept of stiffness matrix. And in this, since we are putting these equations in matrix form, hence it is matrix, and we are calculating stiffness values for each member, hence it is stiffness matrix. So stiffness may be axial stiffness AE or flexural stiffness EI. Okay, so AE or EI are the stiffnesses of the members. Axial stiffness will be for truss members, flexural stiffness will be for beam and columns. Okay, so now we shall start with the generalized procedure, step by step procedure for stiffness matrix method. Okay, so let us see now the step by step procedure to solve a problem using stiffness matrix method. I have listed down all the steps one by one and I will explain one by one the steps. So our very first step will be to find out the number of unknowns in the structure. These unknowns are, as we discussed earlier, these unknowns are displacements. These displacements are nothing but kinematic indeterminacy of the structures. So for stiffness matrix method, the displacements can be either linear displacements or rotations. Okay, so that will be our first step. So most probably when you are solving a problem conventionally, there will be maximum 3 number of unknowns and minimum 2. Then second step is assign numbers to unknown displacements. So giving appropriate number to the kinematic indeterminacies is important. So theta 1, theta 2, theta 3 and so on will be the numbers given to 1, 2, 3 will be the numbers given to respective displacement quantities. Then third is apply fixity in all coordinate directions to get a fully restrained structure. Means what? It means whatever is the external loading, because of this external loading you find out these forces here in step number 4. Apply fixity in all coordinate directions means restrain or make all these unknown displacements 0. Make all these unknown displacements first of all 0, and then you find out forces developed in each of the coordinate directions because of external loading. It means you are first of all applying fixity, and then because of external loading you are finding out forces in the structure. Now we have to solve two types of structures. One is truss, another is beam and frames. So when you have to solve a truss using stiffness matrix method, you will have to find forces in the members, axial forces, and those axial forces in the members will be PL. And when you are solving either beam or frame, in that case force in the member will be moments. because beam members as well as column members are flexural members. They are subjected to bending. Hence, we have to find bending moments in each member. So this is step number 4. Then number 5, determine stiffness matrix K by applying unit displacement to the restrained structure. Means in first step we have found the degree of kinematic indeterminacy, and we have decided the number of unknowns in step number 1. We have to give numbering to these unknowns, and whatever is our first unknown, we have to select this unknown. We have to assume this unknown as unit value. If it is linear displacement, unit displacement will be assumed 1, and if it is rotation, it will be assumed as 1 radian. So we have to find out stiffness matrix by assuming one by one our unknowns, apply them in the restraint structure, and find out what are the stiffnesses of the different members. So we will get this while solving actually a problem. Okay. Then observing final forces in various coordinate directions, note final forces P. Then form and solve stiffness equations. Delta is equal to K inverse into P minus PL. So this is our basic stiffness matrix equation, where there are delta unknowns, which is nothing but kinematic indeterminacy. K, it will be formed from step number 5. P forces will be formed from step number 6. PL will be found from step number 4. Okay, you substitute all these values in simultaneous equations, form a matrix, solve it, and after solving you will get unknowns, okay, linear displacements as well as rotations, and use joint displacements to find out final forces in the members, either axial forces or like flexural forces. Flexural forces means nothing but moments. So I hope you have understood all the steps, and these steps will be more clear when we will be solving actually the problems. So if you have any difficulty in understanding the basic concept of stiffness matrix or these steps, do comment in the video. Thank you.